Okay, let us proceed. Thank you for coming back. So I was making the recap of this. So you go through this. These are the things that I've been talking about. Go through them, but I would like to emphasize more what is range, because here they talk about range in air. So we say that gamma rays have the highest range, followed by beta and then alpha particles. So what is range of a radiation? Is the maximum distance covered by a radiation before it is absorbed or before it is totally absorbed. So the gamma radiations, they have the largest range. It means that they cover a very maximum distance before they are totally absorbed. Showing that gamma radiations penetrate through matter, penetrate through almost everything apart from lead. So it means that they cover up a highly maximum distance before they can be absorbed. So this is what we are meaning. There is an atomic bomb that took place in Yakushima, Japan, some time back, but the radiation did not reach Africa. But right now, even right now, the radiation is still there. So it means that those gamma radiations cannot reach Africa, though they can move. So they can move a certain distance. So it means that gamma radiation can move a certain distance before they are totally absorbed. So it means that if they are moving from Japan to Africa, they are going to be absorbed on maybe somewhere on that way. So they may not reach, but they will cover a bigger distance before they get absorbed compared to other particles like alpha and beta. This is what we are meaning by range. So beta particles have 3 and this one have 0.05 meters in air. And they are saying ionization is the process of changing. We talked about ionization where we say that the alpha particles have got a high ionizing power. So what is ionization? Is the process of changing the neutral atoms of a gas into positive or negative ions. So if a radioactive substance, if we are exposed to radioactive substance, or air is exposed to radioactive substance, air particles around that radioactive substance will be ionized, meaning that they are atoms of the air, because this air that you breathe in is oxygen. So it means that around you there is oxygen. And oxygen has got molecules, oxygen has got atoms, oxygen has got electrons. So deep you go into the atoms, you find very many things. So the oxygen or the gas or the air around you can be ionized with positive and negative charges or ions. Okay, so that's what we call the ionization, giving a positive or a negative charge to the atoms of the gas. All right, so let us look at detectors of radiation. What do we understand by detectors of radiation? So we can go back here. This chapter, I've summarized it, but you need to write the notes before you go to the next part. So here you draw a table and show you how the table is looking like, and you get to know. So you draw a table like this. This table having 4 columns, can leave 1 page, and you have a table of 4 columns like that. So you leave 1 page and write the notes there for that table there. But we can go to this other part where we have the detectors of radiation. So as for me, I will not leave a page. For me, I will just skip and I just put here detectors of radiation. So I've explained, don't do what I'm doing, so you have to leave space. And you write the other table and then you write everything in the table. Are we together? Are we together?
Yes, teacher.
Have you had breakfast, members?
Not yet.
Yeah? Olivia?
Yes.
You've had
Yes,
breakfast?
teacher. Yes.
Yeah, I thought you were just on an empty stomach. I'm saying you breakfast.
Ah,
What about
I
to
knew it.
Darius? Darius, have you
Yes,
eaten
teacher.
something?
Yeah.
Because you need energy. Brain needs power. You get it?
Yes.
If you have not eaten, Cynthia, I think Cynthia eaten really. If you have not eaten, you take some water, okay? Because water is brain power. That's why for me, I'm taking water right now. Okay. Let us look at the detectors of radiations. What do we use to detect a radiation? The things of telling you. Now, yesterday when the bomb happened, they were sending away people. Move away. Do not come close to this. This is a crime zone. What and what? Do you know the reason? Do you know the reason why they were sending away the people? Some of you think that maybe those security men like Isaac in saying this and this. No, they are trying to protect you because they don't know what they are dealing with. They didn't know what they were dealing with. So they need to use some things to detect. Was it an atomic bomb? What was it? They need to find out. Some things you can laugh. Was it an atomic bomb? Does it radiate? You need to find out. So what do they use? They use the things that we are going to study right now. One of them is the ionizing chamber. Ionization chamber. So right, ionization chamber. So you can first list them. Ionization chamber. There is the Geiger-Müller tube. Geiger-Müller tube. Or sometimes it is called the GM tube. This one is the one which is commonly used because of its sensitivity. There is what we call also the cloud chamber. The cloud chamber. Now, when I talk about cloud, don't think about the clouds. My neighbors, my stratus, and my what? No. Olivia, have you heard?
Yes, teacher.
Hey, so here I'm talking about a cloud chamber, but we are going to see, maybe inside there is a cloud. So for both expansion types and diffusion cloud chambers. So what's very important is write a cloud chamber. The other one can just leave it. Just wasting our time. So the fourth one is, this one is called what? Solitary, let me ask who? Wendy.
Yes, teacher.
Pass, please. Pronounce this one.
Scintillation.
Well,
Scintillation counter. Scintillation counter.
Scintillation counter. You got it, you are linguistic. I didn't know. Thank you very much. Okay. Scintillation what? Counter. But what we are going to look at mainly, we are going to look at these two. The GM tube and also the cloud chamber. So maybe when you go to A level, you look at all these, but A level, let us look at only these two. So what am I going to start with? I'm going to start with the GM tube, the Geiger-Müller tube. So we write the Geiger-Müller tube, GM tube, and underline it. The first thing we are going to do is we are going to first draw a diagram of how the GM tube looks like. Now, in our notes here, we don't have a GM tube. Out together, we don't have a GM what? We don't have a GM tube. But what we can do, Okay, thank you, Christine, for that question. What of a photographic plate? Is it also a detector? No, my dearest, it is not a detector, but it is a film. It is a film. Where?
I was telling you to come and get soil. You just ran. Don't look at me.
Okay, gift. Make the baby not to cry. So it is just a film. Like it's the same way how you may have a camera, and the camera there is a photographic paper where the photo goes. So even a photographic plate, it is a plate that is used in the X-rays so that we can have a photograph of the fracture of the bone or of the what. So that is a photographic plate. It is also used in the cloudy chamber. A photographic plate is also used in a cloudy chamber. And we study the tracks. These tracks, these are these ones, we call them tracks. We study the tracks of alpha and beta particles. So it is just a plate used to study the tracks, or a plate in X-rays that we use to have a photo on it. So let me show here something here. I want to show you the, that is the GM tube. Before that, come on, she's smiling. Okay, thank you. But we don't want to know. Let's see this one. Okay. Yeah. Here. Come on. Yeah. Okay, it's explaining. Maybe you can take this one. Okay, that is the GM tube. This one here is what you call the GM tube. Now, let me share with you. Let me share with sound so that you can hear what this lady is going to say. And let me increase this. And okay, so you listen. From there, that's where we are going to write the notes.
Radioactive detectors, Geiger-Müller tube. Geiger-Müller tube is the most versatile, useful and very sensitive detector of all radiations. When GM tube is switched on or the radioactive source is removed, the rate meter displays a reading which is known as the background count rate, which accounts between 20 to 50 per minute. A rate meter usually has a loudspeaker which gives a click for each pulse. The Geiger-Müller tube has two electrodes across which a voltage of about 400 volts is applied. A central wire acts as the anode while the cylindrical middle wall of the tube forms the cathode. The tube is filled with argon gas at low pressure. It has a thin mica window at one end through which radiation can enter. When radiation enters the tube, it produces argon ions and electrons. These are accelerated towards the respective electrodes. These accelerated electrons will collide with other argon atoms, causing further ionization, producing an avalanche of electrons. On reaching the electrodes, the ions produced a current pulse which is amplified and fed either to a scalar or a rate meter. Thank you for taking time to watch this. A rate meter usually pulse.
So I want us to see here 41 here. Okay. Members, are you there?
Yes. Yes.
Okay, so that is the GM tube. So we are going to write notes just from what she has just said. We are going to write notes, but first of all, let us draw that diagram that you are seeing there. That diagram that you are seeing is what I want you to draw in your books. Is it hard? Is it hard?
No.
Good. So let us have that diagram drawn. I'm also drawing. So let us be the first to finish now. But that's what we call the GM tube. What we call. We are drawing that diagram. We are drawing that diagram, members. So in that diagram, and you don't draw for me a house and you say that the book where the diagram is inside the house. Saying it's hard. So what is very important is for you to draw the anode, and I'm going to ask you questions from what you had. If you want to hear the second time, we shall say about that. Finished?
No.
Because for me, I've finished. Darius, what are you using to draw?
Pencil.
Yeah?
Pencil and a ruler.
You are using a pen?
A pencil.
Okay. Good, 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 good. So I will not ask the rest. They know what I want. So central wire, and we call that the anode. So it has the central wire. It has the metal tube, which is connected to the cathode. The cathode. And inside that GM tube, there is gas at a low pressure. There is argon gas at a low what? At a low pressure. Okay. Why is argon gas at a low pressure? Why is argon gas at a low pressure? So whenever something is at a low pressure, just know that we want to reduce on the collisions with the air particles. So there is no air. Air is there, but it is limited. So that's why it is at a low pressure to reduce on the collisions with air. So gas molecules are not there because what is there, the only gas which is there is argon only. But other things like air, no. So is at a low pressure, and the other thing is to increase on the ionization. The ionization. So if you are finished writing, you tell me. And then you write the notes. You just tell me done, and you write the notes.
Done.
Okay. Everyone done?
Done.
Even Dorian is called done?
Yeah.
Okay. Okay. So let us go back.
About 400 volts is applied. A central wire acts as the anode while the cylindrical middle wall of the tube forms the cathode. The tube is filled with argon gas at low pressure. It has a thin mica window at one end through which radiation can enter. When produced, electrons will kill.
I want to stop there. Now they are saying that this GM tube has got a loudspeaker. It has got a loudspeaker. So before, this is what they showed you. there. This is the GM tube. This is the retimeter, this one here, which you can see the values. This is the one that has counts per minute. You see here? Now this one is count per second. Should I zoom in for you here? Let me zoom that for you and you see. And you see the units which are there. I think you can see it is counts per second. Those are the units. So this one is counts per second. So others can have counts per minute. Those are the seconds. So let me zoom out. Okay. And what you have to know is that this GM tube has got a speaker or a loudspeaker. So whenever it detects the radiation, the loudspeaker gives some funny noise. I don't know what kind of noise, but I wanted to give you that funny noise of how it sounds. I think I will show you later. So it gives some funny, some noise as if some noise as if it is a spark. So that noise shows that there is increase in the pulse or there is a decrease in the pulse. So it has got two electrodes. If you go back to the diagram, it has two electrodes. So it has got the anode. This wire in the middle is the anode, and it has also the cathode. This is the cathode. The cathode is on the casing. The casing is made out of the cathode. The same way how you see a dry cell, that a dry cell, inside a dry cell, there is carbon, that black thing. Inside there is a carbon rod. I don't know if I've ever seen a dry cell, but inside it there is carbon rod, and outside there is a brass casing. So even this one has got a casing, but that casing is connected to the cathode, or it is negative. So the cathode is negative and the anode is positive. You can see this is positive, and that's where the anode is connected. It has inside a gas at a low pressure, and this gas is argon gas at a very low pressure. Now, in front of this GM tube, there is a mica window. This mica window, its purpose is to allow in the radiation to enter into the GM tube. It is made out of thin mica, M-I-C-K, mica window. So we are going to write, but before that, let me first explain. So when the radiation enters, in the tube, ionization takes place. This is what we call ionization. Ionizing the argon gas with the ions of positive and negative. Okay, so the argon gas inside its atoms become ionized when the radiation enters, forming positive and negative ions. So when the radiation enters, ionization takes place, producing argon ions and electrons. Now these electrons, the electrons are accelerated. The electrons will be accelerated towards the anode, and the positive ions will be accelerated towards the cathode. Now this causes collision. So the electrons collide with the positives, and this collision causes more ionization. So whenever a negative collides with a positive, there will be another ionization taking place that generates what we call a avalanche of electrons. What we call avalanche. In your geography, you studied avalanche when you are studying Switzerland or glaciation, and you said it's avalanche. It is, I remember my geography. Avalanche, it is it running snow from the mountain? Is it so? Yeah? Members, are you there?
Yes, teacher.
So avalanche, do you remember that? Or you have never studied?
I don't remember.
Mamma mia, Santa Maria. Okay. Avalanche. Now you learn some geography for me. There's a avalanche, a glacier from the mountains. It's called a avalanche. So even in the GM tube, there is a avalanche of electrons. It means that there are now very many electrons, but these electrons are there due to the ionization that has taken place due to the collision of the positive and the negative ions. So when those electrons are being generated, when avalanche, a group of electrons has been generated, these electrons travel towards the anode and produce what we call a pulse. So whenever electrons move towards the anode, there will be a pulse. And this pulse is amplified. It is amplified and then it is fed into the retimeter. Fed into the retimeter. So once now you will see the retimeter here. If this is the retimeter, you see the retimeter and its pointer shifting to and fro, shifting to and fro. So it means that now there is a pulse that has been detected, or there's a radiation that has been detected. I repeat again, how does the GM tube works? We say that when the radiation enters the tube, ionization takes place, producing argon ions and electrons. Electrons are accelerated towards the anode, while the positives are accelerated towards the cathode. Electrons collide with the positives, producing more ionization that generates a avalanche of electrons. Once these electrons reach the anode, they produce a current which is amplified and fed into the retimeter. And that is the end of how a GM tube works. So let us write the notes here and say that. So the first thing of saying it consists this and this. You can explain that, but you have to know that once you draw that diagram, then you have to talk about everything. So when the radiation enters the GM tube through the what? Through the what?
Mika window.
Through the Mika window. The spelling of window. Window is with N. Through the Mika window, comma, ionization. Ionization takes what? Takes place. Ionization takes place. Let me zoom in that for you there. Ionization takes place. That is it. Now, when ionization takes place, what happens? So we say that negative electrons, negative ions, in brackets electrons, and positive ions of argon gas are produced. Full stop. They are produced. Wow, this is so dangerous. Then the next thing is that electrons are accelerated. Where are the electrons accelerated?
The anode and
Towards the what?
the anode and the cathode.
Towards the anode and the positive ions. Towards the what?
The cathode.
Towards the cathode. Okay. So we say the collisions between the ions cause more ionization that produces a avalanche of electrons. Avalanche. I like that word. Avalanche of what? Of electrons. Okay. Okay, Sherry. We are still studying. You asked me that. So once the ions reach the electrodes, members, which electrodes are there? Which electrodes are there? Electrodes that are there are two. We have the anode and the cathode. Those are the electrodes. Okay. So once the electrodes, once the ions, which ions? The electrons and the positive ions. Once those ions reach the electrodes, their respective electrodes, current is produced, which is amplified and fed into the retimeter. And once it is fed into the retimeter, then we can have the readings from the retimeter. We can have the readings. Sorry about that. Now let me do this very fast. Okay, so that is the GM tube. That is the GM tube. Now, number 2 is the cloud what? Is the cloud chamber. The cloud chamber. Cloud chamber. Now this one, the diagram, I will not draw it, but when you go to A-level, you draw the diagram. It's not very so important. So what you have to know is that what is very important is this part here that we are seeing. These tracks here, the ones which are very important. But you know also how a cloud chamber maybe works. So a cloud chamber, they are saying that when ionizing radiation from the radioactive source enters the cloud chamber, ionization takes place in all. Now, in all the detectors, once the radiation enters into the detector, ionization takes place. So that should be your first point, that once the radiation enters into the chamber or enters into the tube, ionization takes what? Takes place. So they are saying that alcohol droplets in the cloud chamber will collect around the ions, alcohol droplets in the cloud chamber will collect around these ions, forming strings. So there will be alcohol droplets that will cling along the ions, and this will give rise to strings. Now, these strings are illuminated. Illuminated means that there is light that is projected towards them. So they are illuminated. So the droplets or the strings are illuminated and can be seen from the photograph, or they can be photographed by a camera. That's where the element of the photographic plate comes in. That now these kind of strings are going to be formed on the photographic plate, on the photographic film. If they are illuminated by a source of light, now that source of light makes them to be photographed on a film. And what shall we see on the film? On the film, we shall see strings of these droplets, but these strings, they have different thickness, they have different length. What I mean by strings is that these are strings. For example, this one, these are strings. Those are strings. Anything that is a string. So those strings can be observed from a photographic plate or a photographic film that is illuminated by a source of light. Now the kind of thickness and the kind of the length and how straight that they are will depend on which kind of radiation it was. So if it is an alpha particle, I'm going to explain these notes, you copy them up to here. So when it is, if it is an alpha particle, the alpha particle produce thick and straight strings. So the strings are going to be thick, straight, and short, the way you see them. So they produce strings which are thick, short, and straight. Those are alpha particles. That's what you see on the photographic plate. And then the beta particles, you see strings that are long, but they are wavy. If you don't use the word strings, you may call it tracks. So you can see tracks the same way how you see tracks if a car passes on a road and the road is muddy, you see the tracks. Or if it is a snail has passed somewhere, you can see its tracks. So even these ones, when they are moving, they leave tracks of these alcohol droplets on the photographic film. You see the tracks. So these tracks for beta particles are long, wavy, and for those of gamma, they are very short. They are short and irregular, okay, and faint. Irregular, short, and faint. So those are the tracks that you see. Now, we have just seconds which we are left. So we have covered what you're supposed to do, but I have not written these notes. So from here, I repeat, from here, write notes from here, and draw also these diagrams. Download the book and draw those diagrams. For those ones that have questions, maybe about their results, what and what, you want to ask something, you are not seeing this, I'm not, what, where, how can I? You come back in the next session, immediately after this one, come back, or after 1 minute, you come back, and then I explain to you, and then the rest, we shall meet next week, and we shall look at the dangers of radiation. Is it okay?